Hello students, hope you're all well and safe at home. In our previous video, we have learned about motion and its various types like translatory motion, circulatory motion, oscillatory motion, repetitive motion, random motion and multiple motion. Now in this part of the video, we are going to discuss and understand what is scalar and vector quantities, uniform and non-uniform speed, weight. Assume you are standing at this point. Now, if your friend tells you there is a treasure chest 50 kilometers away from home, how long will you take to find it? And which direction will you go? It could be here, here, or maybe here. It is hard to know where exactly it is. You are only provided by the distance, which is one-dimensional information. One-dimensional information like this is called a scalar quantity. Your question to your friend would be, which direction from home? When you are told that it is 50 kilometers in the northeast direction, you have the precise information of the location. This now becomes two-dimensional information, distance and direction. The treasure chest is over here. The dimensional information like this is called a vector quantity. Scalar quantities are one-dimensional and vector quantities are two-dimensional. Speed is a very good example of what we call in physics a scalar quantity. Indication only magnitude but not specifying any direction. So that's what scalar quantities are. Only magnitude but no direction. In the case of velocity, however, direction is stated and that's why it is referred to as the vector quantity. A vector quantity involves not just the magnitude but also the direction. When you add directional information to speed, it becomes a vector quantity called velocity. The additional information makes it more specific. Now let us understand what is distance and displacement. When we move from one place to another, the measure of total length we cover called the distance. Is distance a vector or scalar quantity? Think about it. If you can say someone traveled 20 kilometers from this point, we can't really tell where they landed up. Maybe here, maybe there, or maybe they went just around the circle as it is not specified. Direction, it is a scalar quantity. That brings us to displacement. So what is displacement? Distance with direction is displacement. Ankit has to reach the post office at point D from his home at point A. He does not know the direction to the post office. He covers the distance A to B, then B to C, and then C to D to reach the post office, which is 10 kilometers. Thus, the distance Ankit covers from his home to reach the post office is 10 kilometers. Now look at the dotted line AD. This is the shortest distance from Ankit's home to the post office. If Ankit had known the direction to the post office, he could have taken the shortest distance and would have had to cover fewer kilometers. The shorter distance that takes direction into account is called displacement. So, distance is the total length of the actual path covered by a moving object, irrespective of its direction. Hence, it is a scalar quantity and is denoted by small d. Displacement is the shortest distance traveled or covered by an object from its initial position to its final position in a particular direction. Hence, it is a vector quantity. It indicates the overall change in the position of an object. Displacement has both length and direction. It is denoted by small s. The SI unit of both distance and displacement is meter. Now look at the picture of a ball thrown vertically upwards from point A to height h. The total distance covered by the ball when it reaches the ground will be equals to h plus h equals to 2h. In this case, displacement will be 0 since the ball comes back to its initial position, that is A to B, back again from B to A. The direction toward north is taken as positive, the direction towards south is taken as negative. Similarly, the direction toward east is taken as positive and the direction towards west is taken as negative. So, h meter north gets cancelled by h meter south. So, the displacement of the ball would be 0. Uniform speed. When a body travels equal distances in equal interval of time, speed is said to be uniform. You can see the movement of the car with uniform speed. The speed of the car is 10 meters per second. Other examples of uniform speed are movement of planets around the sun, moving hands of a clock, non-uniform speed or variable. As the name suggests itself, the speed of a body is said to be non-uniform if it covers unequal distances in equal interval of time or vice versa. Here, the car is traveling unequal distances every second. So the other examples are a car moving in a busy marketplace, a train pulling out of a station. Average speed. If a body in motion does not cover equal distances in equal interval of time, we find the average speed of motion of that body. The average speed is calculated by finding the ratio of the total distance traveled by the body to the total time taken for the journey. That is, average speed is equals to total distance traveled in total time. For example, a car has traveled a total distance of 4 km plus 8 km plus 3 km, which is equals to 15 kilometers, and the time of travel is 9 a.m. to 12 noon, that is 3 hours. Hence, the average speed of the car is 5 km per hour. Now let's see what is weight. Weight is a force with which the earth attracts a body towards it. Every object is attracted towards the earth. The pull of gravity on objects on the surface of the earth is called acceleration due to gravity. This attraction decreases as we move upward from the center of the earth. It is maximum on the surface. The SI unit of weight is Newton. The weight of a body is the force of gravity G acting on a mass M of a body. So the weight is given by W equals to mass into gravity. Since the value of gravity varies from place to place, so for the convenience of calculation, acceleration due to gravity is taken as 9.8 meter per second square approximately. The gravitational pull on an object decreases as its distance increases from the surface of the earth. So, the gravitational pull acting on an object at a distance of about 3000 km from the earth is less than that of the surface of the earth. Hence, the weight of the object at that height will also be less. As acceleration due to gravity would be different on moon as compared to on the earth. The gravitational pull on the surface of the moon is only 1/6 of the gravitational pull on the earth. So, on the moon, a body weighs 1/6 that of its weight on the earth. Measurement of weight. The weight of an object is measured with the help of a spring balance. Now let us see what is spring balance and how does it work. A spring balance consists of a spring, the lower end of which is attached to a hook through a long rod. This is a pointer attached to the rod. The pointer slides over the vertical scale graduated in gram force, that is GF, or kilogram force, that is kgf. The body whose weight is to be measured is suspended from the hook of a spring balance, taking care to see that the balance is vertical. The pointer shows the weight of the body directly. The principle on which it works is that the extension produced in a spring is directly proportional to the gravitational force acting on it. That means that when the force is more, the pull on the spring is more. So the extension produced will be more and vice versa. Now let us do an experiment which proves that the force of gravity is directly proportional to the mass. If a body is suspended by the hook of a spring balance, a force of gravity pulls the body downward, but an equal and opposite elastic force directed upwards acts on the weight. When the two forces become equal and opposite, the body stops moving. And now you can see the differences between the mass and weight on your screen. Hope you have understood and enjoyed. Thank you.